So hi there everyone, I am Yusuke and I'm an engineer with a couple decades of experience at a few companies like Zillow, Google, and now GM. Thoughts from this post are my own, but I wanted to start this video series on agentic coding, and so we're just going to give a demo of that. Today I want to demo basically making a whole code base from scratch, completely hands-off, and we'll talk about the building blocks to get there. So we'll do a demo of kind of like the bootstrapping that I put in the repository to get agents to understand and know what they need to do. We'll talk a little bit about how we manage work across one or more agents using tools like Beads. And then we'll talk about how we actually kind of execute and orchestrate that with a little orchestrator that I wrote called Lelouch as well. For today's workflow, there's 3 core attributes that I think are worth kind of understanding. One of which is that this is all going to be local. This is just kind of a choice I made, but the work trees here are going to be all running on this machine. There are ways to make this happen remote, but we're going to skip that for now. There's also going to be parallel execution, or rather the ability to do parallel execution. So that was one of the design constraints. I wanted to be able to scale this up if I need to. And again, this is going to be fully autonomous. The idea is to kind of be hands off versus sort of the coding workflow with agents where you may, have them generate some code and then you do some review and then fix it and so on. So sometimes I find I need to do a little bit of that, but this is going to be demoing kind of what that hands-off workflow looks like first. So one thing to note, as of right now, March 2026, I don't see all of the guardrails being necessary. They kind of just like do this with literally any project. I don't think that I would build a production web application and deploy this and have confidence that's going to sort of satisfy, for example, safety requirements, things like privacy, without some additional human review. So there's a specific type of project that this type of development works well in. And so, use at your own risk. In my case, here's kind of 2 of the different archetypes that I see. These like self-contained smaller projects kind of work best. So I built like multiple VS Code extensions for myself this way, little web utilities like single page websites that solves paper cuts on my side. And Lelouch, like the tool orchestrator that I've worked on, is also written in this. There is still, I think, a lot of manual effort required for more large-scale systems. And so I just want to note that for my personal workflows as of this particular recording, I am still relying a lot on, more of a manual cycle where it'll all have it generate some code, I review, and so on. So you really kind of have to choose the project that you apply these patterns to. The project I'm going to try to create today is a web visualizer for this tool called HeapTrack. So what you'll see here is this is the HeapTrack sort of Git repository. It's hosted on KDE's own GitLab instance, but effectively it's this cool tool that you can use to profile the memory allocations and leaks that are happening in like a C or C++ or Rust application. I really like it, but I don't have the ability to run the GUI on my remote machine, and so I would just love a way to just go like host a web page, or maybe get some sort of way to just like load that up myself. And so I made this empty repository HeapTrack web UI. I've cloned that out, and we can go ahead and get started. So the first thing we're going to do is just bootstrap the repository with just some scaffolding that I have found works well for agents. So I have written this agentic-bootstrap repository and kind of pushed it under my own GitHub. That is kind of helpful to me. It documents my workflow, but if you just kind of walk through the core bits of it, they're pretty generic to any sort of like orchestration loop that you'd like to perform. So what I mean by that is inside of this templates directory in the repository, that's where I've got all of my generic stuff. you'll see that there is an agents.md, which is what these agents like VS Code or Cursor are able to read. And they just kind of include a lot of the rules of the repository itself. So what I've found to be helpful is putting in a lot of the how you get work done, so that you can make sure that that's consistent. So you'll see here, there's some rules around committing code. I talk about how CI has to pass. I talk about how linting works. And I, basically say, please always update the documentation. So there's some information about what was done and some way for me as a user of the code base to be able to understand it. The other part that's kind of interesting is this specs directory. So inside of here, we'll talk about this when we actually build out the repository itself, but this contains a lot of various explanations of how the code should be designed. So it's a way for you to have one agent that's responsible for the design side of things, and for an executor agent to be responsible for picking up some of those items, referencing that design to be able to go ahead and implement that. So that's the basic structure. And then, you'll have a README that contains information about what the repository is for, maybe some basic user guides. And what I've found is that works well as kind of like a landing page for the agent to kind of get some context on a repository, which is why, going back to agents.md, it says study the README as the first thing. One more thing we're going to do is, now that we've got our empty repository, when I want to bootstrap something, I can go ahead and go into my scripts directory, install. I specify my target directory here, which is going to be that heap track web UI. And all it does is just copy the files over. So now we get to the point where we actually have to write the design. So there's a couple techniques that I've seen online for this, and I've tried myself with great success. One of which is you just kind of write everything yourself. You write the README, write the specs, and then the other one is you have the AI actually kind of grill you and ask you about what type of project you want to design. So for the sake of this particular demo, I just want to have the agent grill me and kind of take care of some of that, because that's the most automated workflow, right? So what you can say is, in your preferred agent or editor, just say, interview me about the purpose of this project. I would like to build a UI to read heap track files and write them. And expose things like flame graphs. Show me the largest memory allocations and where they are occurring. And one more thing before I do that, I don't think I've actually equipped my project with everything I need. So one thing that you'll want is basically an example file, so it knows how to read them. And so here I just created a random one. Heap track can profile any application here, but you'll see that now we have this heap track file in the CSV format that I can use, that the agent can use as a reference. But back to the grilling, let's see what it has to say. So here you'll see it kind of asks a few things. I'll say, okay, let's be purely client side, parsing the JS or DMS back service. So I will say it should be client side web app. And load the file. Let's also say the front end framework should build on React and additional best practice libraries for front end development. Consider best practices like dark mode, and reactive design. And users will drag and drop, and then please add all features and visualizations. Then you can say with this design, I'll answer its tech stack question too. Primarily simple pulling in dependencies like React Router as needed. So please write as many specs, as many design documents as needed in the specs directory. So with that, potentially I might go back and forth and review the things that are in the specs, which I might do offline. But the general idea here is to kind of illustrate this is how you get your bootstrapping done. It's going to look at these, it's going to think about the design, it's going to go write a bunch of files into specs. Now we're back, and the agent has produced a few different designs on things like architecture. It talks about what types of libraries it should use. It talks about features. I've just taken a look at these offline, and they generally look okay. UI design, I deleted a couple weird things where it was calling out very specific fonts for like the typography, or saying things like, oh, it has to use like the Apple's clear glass for style purposes. All of that kind of seems superfluous, so I kind of dropped those. So with that, now we're actually able to start building out the issues that we need. And this is another thing that we can kind of defer to AI. So so to start with the issue management itself, I use this tool called Beads. It was made by Steve Yegi, who's been doing a lot of work in this space. But you can kind of look that up. That's really kind of just a matter of running this BD init, not contributing to someone else's repo. It's basically ready to go. It's effectively just kind of a local issue management server. And you can do things like, create new issues, you can list them. And the idea here is that this is going to be how your agent is going to manage work. You might have already seen this kind of described in the agents.md that I was referring to earlier. But the idea is that the agents will create new issues in this Beads issue database. You'll create the first set, and we're going to get an orchestrator in a second here that's going to pick off those issues. So we've done that, and now I'm going to go back to my agentic bootstrapping here. And what I've been just kind of trying to do is automate or sort of codify a lot of my approaches here as much as possible. Really, now I just kind of add in this prompt. And this says, hey, let's go ahead and go create some issues. So I should probably add a little thing to go basically read through and add the specs directory. And, I basically just have some scaffolding that says, also please study the README, check the production deployment to see where the gaps are. Okay. Yeah. So normally when I do this, I have a sort of GitHub CI that I start running that will basically go and deploy this page. And that's why it says check the production deployment. And actually, I guess in this case, I can go ahead and do that too, because we're just building this like single page app again. So you see here, it's gonna basically think about this a little bit. I've already initialized Beads, so it's gonna create some issues in a second here. So here's the output of the final issue here. And so you'll see tells me, yeah, let's go ahead and added a bunch of the basic scaffolding, lint and CI issues as well. But you'll see here it's kind of scanned the spec, and now we have all of these individual BD issues that we can look at. And this might be a good time to introduce the web UI as well. So you can use BD as a command line tool, but what I've found is there is this Beads sort of visual issue management extension in codebase editors that is really nice and useful. So here you'll see it's got all of the individual issues that I'm working on. Study README, implement the drag and drop for ZST files, check the production deployment. Yeah, and so it's got basically kind of all the individual issues. And if we need more, the agents.md kind of describes, please go re-add new issues into the database as necessary. So that's kind of how you get this like continual loop where the orchestrator may add new issues as it needs to that are more granular. But this is enough. And so now that we have this, we can work on the orchestration side of things. So next up, we have workload orchestration, and this is where this tool I wrote called Lelouch comes in. I'll probably put the GitHub links in the description so it's easy to find. But the overall approach here is that you just kind of just orchestrate, the work of pulling off the individual issues in the Beads database by priority, and then executing them in one or more work trees. So in this example, I'm not going to necessarily create a new work tree, but you basically go do git work tree add, create that sibling directory, do this like Lelouch init function in there as well, and then you suddenly have 2 workers, and you could do the same with 3 workers and 4 workers and so on. But this pattern was designed so that you could actually scale this up if necessary. But the general way that Lelouch works is it pulls them off. And so the approach that takes is you specify one executor type. And so there's this config.toml that exists in your config directory that contains a list of all the repositories. When you start Lelouch up, it monitors all of them, pulls issues from those Beads tasks. You can add things like pre-prompts if you want, and you can kind of go from there. So what I'm going to do now is basically initialize Lelouch here. And that's with this, where you'll see here I'm going to initialize it. In my case, I'm going to use the Gemini CLI and the Flash preview version of the model because that has less of a limit on the coda. The pre-prompt I'm going to go put in is run tests, commit, and push. Just for whatever reason, I found that it doesn't honor my agents all the time, so just like being double careful there. And you'll see here that it adds that particular configuration in my Lelouch repository. You'll see it's kind of has a different repository that's pulling work from, and it can go execute that as well. But that's basically it. After that, you can go hit Lelouch run -v, and you'll see here that this is mostly just debug output of Lelouch itself, but it sees the first issue. It moves the issue to in progress. So Beads has some state management inside of it that makes it very easy to kind of see the state of issues. The idea is that the agents would go update the status, and that's been kind of great. And if you look at this, this is kind of a feature in Lelouch, but it actually adds the response from the agent itself into the working notes. So if I wanted to, I could go ahead and follow along and just see what it's up to. But generally, I don't. I just say, this is great. And I can just kind of move on. So it does some weird stuff sometimes. Like, I don't know why it's using Jujitsu when I cloned this repository using Git. So I'll take a look at that. Probably some weird instruction on my side. But for the most part, this is kind of hands off. I don't really touch it from here. It's just going to pick up work. It's going to enqueue the next unit of work. And I walk away and see what comes out of it. So here we are now at the end of the prompt, and I think it's gotten as far as it can, but now it's stuck. But I thought it's a good time to show maybe kind of what's happened and how I deal with next steps. So you can see here it's finished all the issues. I could take a look at these, and one nice thing about this Lelouch tool I wrote is that it shows me the output, so I can get a good sense of kind of what it did. Kind of at the end of where it landed was effectively having this gaps.md file that it chose to write itself, and it looks like it's actually not really there yet. So I'm not sure why the agents.md, which states the instructions around the issues, kind of ignored that, but that's where there's some prompt engineering on there to go take a look. But in cases like these, I'll just go ahead and probably start a new chat and say, study readme.md. There are gaps in gaps.md that are not yet implemented. Please go create BD issues for them. Right? And so when that's ready, I can go ahead and also start my Lelouch V. So it's ready to kind of pick up these new tasks. And then we're back off to the races. So we're going to fire off and schedule those issues and see what happens. All right, so fast forwarding a bit, we're at the point where all of the issues have now been closed. So what's interesting is it didn't actually complete the checkboxes in the gaps.md or delete it or anything like that. That was me not giving it those explicit instructions. So what I would probably do in this case is just think about how to kind of incorporate this into the agents.md so it will delete those in the future. I kind of like gaps.md as a succinct list that would be maybe easier for an agent to quickly see what kind of work needs to be done. So I'll probably adopt that pattern in my agent bootstrap in the future. But we're here now, and so it's time to kind of give this a test shot. Now what I'm doing here is just, opening it up. The README has been populated and gives me some nice instructions to go run the tool. And what I can do here is now I'm at the tool, I've loaded the page up, and I can go ahead and try to load the TXT, and you'll see here that it's kind of funny. It's profiled the command, right? This is what I ran. But you can see it's got the flame graph here. I can click it. What I've kind of noticed is actually there is some weird little sizing issues already. So you'll see here, like the allocation information is already kind of included in here. But it's on this outside of the window that's kind of contained in. So I'm finding small issues like this, but for the most part, this is a very functional project that I can go ahead and use for my own purposes, which is great. If I find issues like these, this is where I've got a couple options here. One thing is if I want, I can go ahead and type BDQ. I say something like, another bug I found earlier was it didn't actually accept the ZST file. So fix the bug with the .cst file, not loading the flame graph UI afterwards, or any UI afterward. And that'll go ahead and file this issue. And then I've got Lelouch running in the background, so it's going to go pick that up and start working on that pretty much right away. Another one is some of the windows are hiding the output, such as the flame graph, such as the memory allocation table is hiding the allocation size. Please fix, right? And after that, basically at this point, it's kind of off to the races. I can use this as sort of the way to do background work, or if I really wanted to, I could go to the right-hand side and kind of do the more hands-on coding. Some of the other things I'll do is probably just like look at the code in the code base, and as I see something's wrong, I'll just kind of tell the agent to go fix that, like refactor a function, or if there's some like abstraction that's not using very well or is duplicating code. Those are the types of things I fix. And generally what I try to do as I'm thinking about this is trying to put those types of improvements and codify them back into my agentic bootstrap script. So I don't have to effectively like learn the same lesson twice. I view it as a way for me to codify the best practices that I care about and try to slowly teach the agent over time as well. You can be even more hands-off. Another thing you could do is just like add a generic one that says like, please open a web browser and test the UI, report any bugs via BD. And that's also a way that it can just kind of like do its own thing, and you'll probably catch a few issues, and you can look at the Beads database later to kind of see what it caught. So that's it. I've done this with 4 or 5 other projects at this point and had pretty good results. And here's my takeaways in general from this process. I think a lot of it comes down to making sure that, first of all, your agents have a good playbook on what they're supposed to do. Like they're, creating, running all of the tests before they push, creating the CI first, getting that bootstrapping, getting the formatting in, so there's no, really messy commits that happen because they just don't have that type of guardrail in there. Understanding sort of what they should do in each step of the process, like doing the commits and push, has really helped the agents stay on the rails. The other part of things is there's model of issues and workers is a really powerful model, right? It's really simple. Just have a place where your agents can pull work and add new work as time goes on, and have a bunch of workers that can orchestrate these agents for you, and you're off to the races. This can expand pretty well. You could have a issue to do code review. You could have other workflows. You can have them kind of like find bugs, but you can do a lot and just kind of walk away and have the agents do the work for you. The last part is, from my perspective, I think this particular model that I've showcased only works well for self-contained projects that aren't really subject to critical security issues, or maybe deploying directly to a SaaS for now. I didn't add a lot of the guardrails that I think are absolutely necessary, like things like safety audit, security audits, reviews. I think some humans still kind of has to be in the loop. I put this like for now because I believe that there will probably be an ecosystem of guardrail tooling that's going to actually expand the types of things we can do safely with AI. Maybe some discrete, assertion on things. Maybe there's a penetration test suite that you can run. But for now, I would only feel comfortable doing this for smaller projects or projects that are just so self-contained, like a game, or maybe it's just like something that you run locally. But this is kind of the start of the journey. I think we're going to get to a point where eventually you can tackle these larger projects, and I think building the muscle to know what types of patterns work and starting to experiment with is really valuable. So thanks for listening. Thanks.